welcome to all of you. For all the past 2 days, as I repeated yesterday, I want to repeat it again. Your support has been unbelievable. So please continue supporting me further. So we will make more productive videos. So in this session, now we are going to see a new chapter called Inverse Trigonometric Functions, wherein we are going to see all the important concepts of it along with some important practical numericals. So by the end of the session, all of you will be aware of how this inverse trigonometry is being applied, and also you will get to know more simple techniques how to solve the problems under ITF. So as I told you, remember the blueprint. The marks for ITF, you just refer to the previous video. So you refer to it and then make a note of it while preparing by yourself. So I wish you all the very best and looking forward for continuous videos as well. So thank you. Welcome to this session. In this session, we are going to start easy chapter which is called inverse trigonometric functions. So in inverse trigonometric functions, I will explain you what are all the important things that you need to study, along with some important numericals that are very important for the examination point of view. I will be also teaching you a lot of shortcut techniques as well. So let us go into the session now. ITF. So in ITF, you have some important topics. First thing which you need to learn about ITF is the trigonometric table. And after that you need to learn the domain and range. And finally you need to learn the most important thing, which is nothing but properties of inverse trigonometric functions. Of course, this properties of inverse trigonometric functions is deleted as per the examination point of view, but still you need to learn, because in differential calculus, that is in continuity and differentiability, while we are dealing with it, this topic is included, as there will be many questions asked from this trigonometry and inverse trigonometry combined together. So you need to learn this properties of ITF. That is a very important topic. So okay, now let us go into this one by one. As I told you, these are all the three topics, and then also we will deal with important numericals. So these are all the four topics that we are going to cover today. So now we go to the trigonometric table. I will explain you in short and simple way how to construct a trigonometric table. You might have studied this in your 10th standard. If suppose somebody have forgotten it, there's no problem. Using this method, you can very easily construct a trigonometric table. Let us see how the table can be constructed. Okay, trigonometric table. I am writing here the heading. Now please listen to me carefully. Sin theta you can write here, followed by cos, followed by tan. These are all the basic ratios, sin, cos and tan, followed by the reciprocals. Reciprocal of sin is nothing but cosec, and reciprocal of cos is nothing but sec, and reciprocal of tan is nothing but cot theta. So now you can write here at the top 0 degree. We can convert that into radians later, but now we will learn it in degrees. The same way how we learned it in 10th standard we can learn, and after that we can do it in degrees. So 0 degree, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now if you have forgotten the values of sin theta, it is better to remember, but if you have forgotten, I will teach you a very shortcut technique. Just draw a number line from 0 to 1. This should be done in the pencil in your rough column. Don't do it in the fair. Just draw a number line from 0 to 1 and add 1 by 4 units to it. If you add 1 by 4 units to it, so you get 0 plus 1 by 4, which is 1 by 4, 1 by 4 plus 1 by 4, which is half, half plus 1 by 4, which is 3 by 4, and 3 by 4 plus 1 by 4 gives you 1. Now you have to take the square root of all these values and then write it in sin theta. So root of 0, it becomes 0, root of 1 by 4, which is half, root of half, which is 1 over root 2, root of 3 by 4, which is nothing but root 3 by 2, and root 1 is nothing but 1. Now for cos, you need to write the values in the inverted fashion for sine. So inverted values are 1 root 3 by 2 and 1 by root 2, half and 0. We all know that sine by cos is tan, so we just divide these values to get the values of tan. So 0 by 1 is 0, 2 by 2 and 2 will get cancelled, so you get 1 by root 3, and both the numerator and denominator are same. You get 1, 2 and 2 similarly get cancelled, so you get root 3. 1 over 0, denominator is 0, so infinity, not defined. So cosec is just nothing but the reciprocal of sec, so it is 1 by 0, which is infinity, and 1 by half, which is 2, and 1 by root 2, that is root 2, and 1 by root 3 by 2, which is 2 by root 3, and 1 by 1 is 1. And for sec, you just need to write the opposite of cosec, from that is values from right to left. So you get 1, 2 by root 3, root 2, 2 and infinity. For cot, you need to write the values from right to left of tan. So you get infinity, root 3, 1, 1 by root 3 and 0. So that's all. The trigonometric table is constructed. We have learned it. We have learned how to construct a trigonometric table now. And now what we do is we just write these values in radians. So 0 degree is nothing but 0 radians. 30. You can write 30 as 180 divided by 6. So 180 is pi. So you can write it as pi by 6. And 145 you can write it as 180 by 4. So it is pi by 4. And 60 is 180 by 3. So which gives pi by 3. And 90 is 180 by 2. So it is pi by 2. So now you have learned the trigonometric table successfully. So we need to apply these trigonometric tables necessarily to compute the values. Hope you all have understood how to construct a trigonometric table. Now let us go into the next part of the lesson. The next part of the lesson is nothing but domain and range. Of course, this is not as important as we have got a lot of shortcut techniques to find out the values. So just if you for some important MCQs this may be required. So just we will be writing the domain and range tables. So here you have a tabular column function, and I will also tell you how to find out the trigonometric inverse trigonometric values for some important numericals, which we will be discussing it shortly. So function, I mean without domain and range, how to find out the inverse trigonometric values, like that we are going to discuss. So then you can easily understand the simple technique of using this domain and range. Okay, function, domain and range. Okay, now first is sine inverse of x. Sine inverse of x, domain is minus 1 to 1 and the range is nothing but, this is closed interval. I hope you all know the difference between open interval and closed interval. Closed interval is you have to include the values from minus pi by 2 and also pi by 2, and also the in-between values between minus pi by 2 and pi by 2 should be included. But whereas in the open interval you should include values, only in-between values and not the endpoints. So that is the main difference. So similarly cos inverse x, it has got the same domain as sine inverse x, and the range is from 0 to pi. Tan inverse x, domain is nothing but set of real numbers r, and it is range is nothing but minus pi by 2 to pi by 2 in the open interval. Open interval, I was telling, these endpoints should not be included, only the in-between values should be taken into account. Okay, next comes cosec inverse x. So the domain is nothing but all real numbers except open interval minus 1 to 1, and the range is closed interval again minus pi by 2 to pi by 2. So both sine inverse and cosec inverse have got the same range. Now, I mean, there is one value, important thing should be noted is 0 should not be included, because cosec 0 becomes infinity. So 0 should not be included. So sec inverse, next is about sec inverse. The domain is real numbers except minus 1 to 1, open interval. And then range is nothing but, it's the same as cos inverse 0 to pi except pi by 2, because it becomes infinity then. As cos 90 is 0, so sec 90 is infinity. So infinity should not be part of it, so that is not included. Similarly for cot inverse. Cot inverse, the domain is R, set of real numbers, and 0 to pi in the open interval. So here, see, some of these values could be asked in 1 marks. Like for example, they may be asking you what is the domain of tan inverse x, or what is the range of cos inverse x, like that. So for that purpose only we are learning this, and there's no other specific purpose, because for the numericals we are going to do it in a different way, that is based on the properties. So now this is about the domain and range concept. Now we are going to go directly to the properties of inverse trigonometric functions. So these properties are very important for the examination point of view. Let us look at it one by one. Properties of ITF. So now I am going to write a set of very important properties. I am going to write a set of very important properties. These properties will be very useful for the examination point of view. Let us look at it now. So 1a, sine inverse of minus x and tan inverse of minus x. Tan inverse of minus x and cosec inverse of minus x. So I'll write it clearly because it is not clear. So I'll write this one little clearly. Okay. Tan inverse of minus x and cosec inverse of minus x, and the opposite pairs of this, that is the other three ratios, cos inverse of minus x and then cot inverse of minus x and then secant inverse of minus x. See, now this becomes simply minus sine inverse x. Now let us look at that application, how it is being, how we are going to apply it. Minus sine inverse of x. Now let us write all those properties and then let us look at the application. So minus sine inverse of x, this is nothing but minus tan inverse of x, very easy to remember also. And this is nothing but minus cosecant inverse x. For all these things, for this side you have pi minus positive value, cos inverse of x, and similarly pi minus cot inverse of x, similarly pi minus secant inverse of x. This entire first property is gonna be very important for your examination point of view. So now let us look at the second property. There are of course three subdivisions. First thing is sine inverse x plus cos inverse x equals pi by 2, and tan inverse x plus cot inverse x, that is equal to pi by 2, and sec inverse x plus cosec inverse x, that is also equal to pi by 2. So this is about the second property. Now we will see the third property. So third property is nothing but tan inverse x plus tan inverse y, that is equal to tan inverse x plus y by 1 minus xy, and b tan inverse x minus tan inverse of y, that is equal to tan inverse x minus y by 1 plus xy. Okay, now this fourth property, just like the first property, fourth property is very important because this could be directly asked under calculus section. So it will be very useful for you. 1 and 4 are really very important. So likewise you have three subdivisions for fourth. First is sine inverse of 2x by 1 plus x square is nothing but 2 tan inverse of x. Cos inverse of 1 minus x square by 1 plus x square is again 2 tan inverse of x. C tan inverse of 2x by 1 minus x square is nothing but again 2 tan inverse of x. So fourth, just like the first, it is very important, so we will put a box. Okay. Now for the fifth one is not as important as like 1 and 4, but anyway we will just simply see it. Again you have three subdivisions. 3 sine inverse x equal to sine inverse 3x minus 4x cube. B is 3 cos inverse x equal to cos inverse of 4x cube minus 3x. Last, 3 tan inverse x equal to tan inverse of 3x minus x cube whole divided by 1 minus 3x square. Okay. So next, last important thing, we are going to see some half angle properties. So for half angle properties, but before we see half angle properties, I would like to write some more important formulas which will be very useful. Of course, these were the formulas that you have already learned it in your 11th standard. That is the formulas that I am going to write now. Sixth property, you would have already learned it in your 11th standard, which is nothing but sine 2 theta. So it is 2 sine theta cos theta, and cos 2 theta is nothing but cos square theta minus sine square theta, and tan 2 theta is nothing but 2 tan theta by 1 minus tan square theta. Now I will give you my important techniques, that is the seventh one, which will be very useful again. So 1, what did I tell you? What is the next number? 1, 4, 6. 6 is also important because based on the sixth only I am going to tell you seventh. So 1, 4, 6 and 7. Those are going to be really important. After we finish this 7th, we will directly go to the numericals. Yes, 7. So actually you have some more important formulas, but those formulas I will be teaching you guys when we actually see calculus part, not now. When we are actually seeing calculus part, it is a mandatory thing to brush up trigonometry. So at that time I will be teaching you the remaining formulas. Now as of now we will stop with the 7th formula. So 7a sine theta. Now how I am going to write sine theta as, using the half angle, I am going to write it as sine 2 into theta by 2. So now it looks like what? The previous section, sine 2 theta. So which is can be written as 2 sine theta cos theta. So it is 2 sine theta by 2 cos theta by 2. Okay. Similarly, cos theta, I can write this as cos 2 into theta by 2. Now this looks like cos 2 theta, which is nothing but cos square theta by 2 minus sine square theta by 2. So 1 plus cos theta. So 1 plus cos theta So here 1 I can write it as cos square theta by 2 plus sin square theta by 2 plus cos theta. I am applying what we learned it in B. So cos square theta by 2 minus sin square theta by 2. I hope all of you are able to understand, because 1 is cos square theta plus sin square theta. So since it is expressed in half angle, I am trying to express everything in half angle. So now what happens? Sin square and minus sin square cancels out. So you get 2 cos square theta by 2. And last thing is 1 minus cos theta. So 1, just like the previous case, I am writing cos square theta by 2 plus sin square theta by 2. Minus is there, so bracket manipulation has to be careful. So if you do brackets into account, so you get minus cos square theta by 2 plus sin square theta by 2. So now cos square and cos square cancels out, so you get 2 sin square theta by 2. So now we are going to see the numericals. That's it. So we are going to directly see some of the numericals, and we are going to see how these properties are applied in those numericals. I hope this all these properties you are clear with it now. So we are going to see some numericals. After that, we will just conclude this very interesting session. Okay. Important numericals. Say I am going to pick some random numericals. I'm going to pick some random numericals, and let us now first I'll tell you the method to solve, so that all of you are able to understand, and then we will solve some of the numerical questions. Very important numerical questions I am telling. So first thing is, always remember, actually, as I have told you earlier at the starting of the lesson, that only the first exercise you have, as per the NCERT textbook, you have only the first exercise in your syllabus. The second exercise is there for the calculus point of view, not for this inverse trigonometry. So you need to be aware of the properties of trigonometry also. So now we will solve some of the questions under first exercise. So I am dividing the first exercise into two parts. One is the positive values and about the negative values. So let us solve some questions. I will take 2 positive values and I will take 4 negative values. So first let us solve some questions like sine inverse of 1 by root 2, and second case is nothing but cos inverse of root 3 by 2. And now let us take some negative values. See, cos inverse of minus of tan inverse of minus 1, and next is cosec inverse of minus root 2, and finally you have this question, that is tan inverse root 3. We are going to evaluate this value minus secant inverse minus 2. Now let us solve these questions. See, as per the positive values, if the value is positive, then you don't have to worry about it at all, because directly from the trigonometric table you can write the answer. So if you look at the trigonometric table, sine inverse of 1 by root 2, you just see where 1 by root 2 is under sine, and then directly you can write sine 1 by root 2. So the angle should be 45. 45 is nothing but pi by 4, which is the answer. So like that, directly you can write without even complicating things. So the solutions for 1a is nothing but pi by 4. You need not check the domain and range values at all. So that is why I told you, instead of using domain and range, if you know the properties directly you can solve. So now this is the application of properties that what we have learned. So now similarly for 1b, Cos inverse of root 3 by 2, it is again positive value, so absolutely no complication. Directly we are seeing the trigonometric table and we can see that cos of 30 is root 3 by 2. So directly the answer should be 30 degree, which is pi over 6, pi by 6. Now for C, here we are applying the properties because it is a negative value. Cos inverse of minus of. So look at the properties what we have learned. So if we have first property, that's why I told you first is very important. Cos inverse of minus x, you have pi minus cos inverse of x. So we are going to apply that property now. So what we are going to do now is you can write this as pi minus cos inverse of half. Now what happens? Cos inverse of half, everybody knows it as 60 from the table. So pi is 180. 180 minus 60 is 120. 120 can be written as 2 pi by 3. This is the answer. You need not check the domain and range at all. So look at how simple these things are. After learning the properties, these things becomes very easy. So D, 1D, tan inverse of minus 1. So directly from the property, it is nothing but minus tan inverse of 1. So minus tan inverse of 1 is nothing but minus pi by 4. So that's how simple it is. Cosecant inverse of minus root 2. Cosecant inverse of minus root 2 is minus cosecant inverse of root 2, which is again minus pi by 4. Minus pi by 4. Okay. Last 1f. Tan inverse of root 3. It is 60 because tan 60 is root 3. What is 60 now? Pi by 3. Minus secant inverse. Secant inverse of minus 2. So it is nothing but pi minus secant inverse of 2. Now what is secant inverse of 2? It is again 60. So it is nothing but this you can take it as 60. Now if you see carefully, this you can take it as 60. So it's nothing but 60 minus 120 minus 6. I mean 180 minus 60. 180 minus 60. Now this becomes 120. So 60 minus 120 is minus 60. So minus 60 is nothing but minus pi by 3. That's all. So these are all the simple techniques for solving these problems. So with this, the first exercise as per the ITF, the syllabus is over. But now let us look at the applications of some properties that we have learned. We will solve some other questions now. Yeah. Tan inverse of cos x by 1 minus sin x. What we have to do is we just need to write this in simple expression. So now what we are going to do is, now I am applying what we learned for cos theta. So half angle identity. So tan inverse of, I am writing this as cos square x by 2 minus sin square x by 2. So because this is what we have learned, because this can be written as 2 into x by 2. So it looks like cos 2 theta, which is cos square x by 2 minus sin square x by 2. So 1 I am writing it as cos square x by 2 plus sin square x by 2 minus sin 2 into x by 2. So it becomes 2 sin x by 2 cos x by 2. Now if you look at the numerator, it looks like a square minus b square. So nothing but tan inverse a plus b into a minus b. So it is cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. So now in the denominator, if we see, it is of the form a square plus b square minus 2ab, which is nothing but a minus b whole square. So cos x by 2 minus sin x by 2, the whole square. Now what happens is 1 cos x by 2 minus sin x by 2, and here this terms will get cancelled. So you get tan inverse cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2. Now how to proceed after this? Simple thing is you have to divide it with cos. So if you divide it with cos, why to divide it with cos? Because it becomes tan and this becomes 1. So you can consider applying another formula. So that is why we are dividing with cos. So tan inverse of, now if you divide it with cos x by 2, it becomes 1 plus tan x by 2 by 1 minus tan x by 2. Now if you see the numerator and the denominator carefully, we can modify it in our special case. So in our convenient way, we can manipulate this function as tan inverse. Beautifully we can manipulate tan pi by 4 plus tan x by 2 by 1 minus tan pi by 4 into tan x by 2, because tan pi by 4 anyway it is going to be 1. Now how does it look like? It looks like tan a plus tan b by 1 minus tan a tan b, which is nothing but tan of a plus b. So tan of pi by 4 plus x by 2. So now tan and tan inverse will get cancelled. So the final answer is pi by 4 plus x by 2. Why did we do this question for now is, as I told you, these type of questions will be asked in calculus. They will be asking you to differentiate this function. So if you are told to differentiate this function, you should simplify this expression to pi by 4 plus x by 2. And now you know very well that pi by 4 is a constant and differentiation is 0, and x by 2's differentiation is half. So half should be the answer. So that is why inverse trigonometry is applicable in calculus. That is how it is being applied. So now we have come to the end of the successful section. The successful session. We will deal with many sessions in the future wherein we will learn so many techniques like this. I hope this session was really productive for all of you, and looking forward to many other sessions in the future. Thank you.